base of a logarithm function is actually the floor function. Now let's just, a concrete example, let's do, say, the floor of, let's say 3.8. Okay, this reads the floor, this is called the greatest integer function, the floor of 3.8. Now, floor is a very suggestive thing. All right, so the floor of this number is equal to 3. All right, and that's because 3 is less than or equal to 3.8. Less than 4, strictly less than 4. Okay. So any real number in this interval from 3 to 4, where 4 is excluded, has a floor of 3. Now, we're supposed to determine the range of the log of the floor of x of the quantity 9 minus x squared. Now notice here that the domain of this function would be naturally constricted between minus 3 and 3. But a lot's going to get left out due to the nature of the logarithm function. So in other words, the domain a priori would be minus 3 to 3. All right. If you get bigger than negative 3, you would be taking the log of a negative number. If you get bigger than 3, you'd be taking the log of a negative number. Now we're going to take advantage of this, of a nice little property here of logarithms that just follows immediately from the graph. I'll draw just a crude little picture here. Okay, and we're going to use, let's see, we'll call this the a-axis right here. Log base b. All right, now any logarithm function that's unshifted has this appearance, okay? And of course, this would be the point 1 comma 0 right here, since it's the inverse of the exponential function. All right, and so you can see as a gets smaller and smaller and smaller, this is headed south, okay? And so this is just a property of an unshifted logarithm function, okay? Now we do assume that b is not equal to 1. Wouldn't be very interesting if b was 1, so we're assuming that b does not equal to 1. And also b is strictly greater than 0. B is strictly greater than 0. Now that eliminates a lot of these values, a lot of the ranges of values in this interval right here. So in fact, if you take a look at what I've done out here, I've gotten it down to being existing between 2 and 3. Notice that if it was between 1 and 2, the base would be 1. The floor of the base would be 1. So we already have gone from minus 3 to 3 to 2 to 3. All right. Now, so for any x that's in this interval, the floor of x would be 2, and that's where this 2 comes from. Okay. So you see it's fairly easy from here. Now, so if x is 2, it's a very direct substitution. If x is 2, we get log base 205 as the largest value, okay, is the largest value in the range of the function. And also, as x approaches 3 from the left, again, you'd have to be coming in from the left, not the right. All right, this property that we just mentioned is based on the graph, implies this, okay? So again, I think that's fairly direct. We know that this is an increasing function. And so here's what we know right now. We can answer the question. We know that minus infinity is going to be less than the function. Okay, let me write this out. Log okay, floor of x is the base. And yeah, I'm just recopying what these two statements have shown. Log base the floor of x of the quantity 9 minus x squared this is just a constraining inequality on the range, okay, is less than, I guess I should say less than or equal, right? Because we showed it was equal right above, log base 2 of 5. I'll drop the parentheses, but the 5 is log base 2, input argument is 5. Some people like to put the parentheses there. I won't this time. So that is the solution. Okay, folks, the range of our function is a number that's always going to be strictly negative, or it's going to be bounded above by log base 2 of 5. Okay, so it's contained in this interval from minus infinity. In other words, you could, some people might prefer to write the answer like this, just minus infinity paren. And then log base 2 of 5 bracket. Is another way to write the range of this function. Now again, a cool problem. This is from the JEE problem 36. And I really like it. These things are a cut above what you see in the United States. They're just more challenging. But again, either way is the way to express the range of this particular function. You can express it in this interval notation, or you can be more explicit as we've done right here. Hope you enjoyed.